Look at that. You have Parkinson's. Grab my hand and I'll explain it to you. As I grab my hand. Blink once if I can throw you. Didn't answer fast enough. Get that lampshade off your head and let's see what Bozeman has to say. Hit it, Mr. Anderson.
Hi, it's Mr. Anderson and welcome to Biology Essentials video number 83. This is on the signal transduction pathways of Parkinson. And so Parkinson is a disorder of the central nervous system which is caused by the progressive deterioration of neurons in an area of the brain known as the substantia nigra. In a properly functioning brain, these neurons produce a hormone called dopamine, allowing communication between the substantia nigra and another part of the brain called the corpus striatum. The communication between the two allows for a smooth and balanced muscle movement.
Yay, Bozeman!
However, a lack of dopamine results in abnormal nerve functioning, causing the inability to control body movements. As visible in the diagram, in a Parkinson's affected neuron, dopamine concentration is significantly lower than a normal neuron.
He's still going.
In a normal dopaminergic neuron, the dopamine is produced and released through exocytosis, where they enter the extracellular fluid to act as ligands for target cells which trigger pathways that may perform various functions. To this day, scientists are still uncertain of the exact reasoning behind the loss of these dopamine-producing neurons. However, they believe it is related to dysfunctional mitochondria and oxidative stress, which is damage caused by reactive oxygen produced during oxygen metabolism. Typically, cells have mechanisms in place to protect themselves from oxidative damage, but these systems can be broken due to environmental factors such as head injuries, pesticide and herbicide exposure, as well as other neurotoxins. Genetically inherited mutations also play a role in the breaking down of these systems, although they only make up 15% of the causality. The genetic mutations affect many of the proteins and enzymes used in the pathway, such as PINK1, Parkin, and DJ1. These mutations cause mitochondrial dysfunction and also the accumulation of reactive oxidative species, and Lewy bodies, which are ultimately the denatured alpha-synuclein proteins. Mutations are also found in the alpha-synuclein themselves, which may affect protein degradation pathways, which leads to the accumulation of Lewy bodies as well.
Hey, I got us some coffee.
The mitochondrial dysfunction and Lewy body accumulation in dopaminergic neurons may be responsible for their premature degeneration. Another effect of the mutations is the impairment in dopamine release, and also the signaling pathway dopaminergic neurotransmission. As for environmental factors, neurotoxins damage the mitochondria, producing reactive oxygen and resulting in more Lewy bodies.
You gonna finish that?
In summary, all of these factors contribute to the premature degeneration of dopaminergic neurons, which result in decreased production and release of dopamine, thus depriving the ligands for many functions, notably motor.
What year is it? Lampshade guy! Let's get that off your head. The Parkinsons must have killed him. Well, I guess now you know how important those dopaminergic neurons are. Yeah, it was either that or the fact that you threw me 200 feet into the air. Well, had you not brutally murdered me, what kind of treatment could I have gotten? I'm glad you asked! Hey everyone, it's another lazy way of relaying information because animation is hard and frankly, I'm done trying on this. But I digress. Treatments and cures for Parkinson's. While there is, as of yet, no cure for Parkinson's, there are treatments to ease your pain before you inevitably die of jazz hands. Number 1. Carbidopa levodopa. Sounds like a spell, but unfortunately does not float you away from your premature demise. This drug passes into your brain and is converted into dopamine, which cannot be directly administered itself. While this is currently the most effective treatment for Parkinson's, as the years go by, you start to build a sort of immunity to it, and its effects lessen. Number 2. Dopamine agonists. This is a family of drugs that mimic dopamine instead of changing into it. Although less effective than carbidopa-levodopa, they can be used to help support it. Number 3. MAO-B inhibitors. Sounds like a Chinese dictator, but is hopefully at least a little more effective. What it does is it inhibits monoamine oxidase B, an enzyme that metabolizes dopamine. In other words, it takes away something that takes away dopamine, which results in more dopamine. A lot of communism jokes I could make about that, but frankly I don't have the time. Number 4. Anticholinergics. These medications were used to help control the tremors associated with Parkinson's and thus eliminated the source of most Parkinson's jokes. Cool, right? Wrong. Side effects include impaired memory, hallucinations, constipation, impaired urination, and dry mouth. That sounds less like medication and more like waking up from a coma. I think I'll take my chances with the tremors. Well, that's all well and good, but it sounds a lot like you're making fun of people with Parkinson's. That's enough of that. How do you turn this thing off? Whoa.